Okay, so this is going to be the first video for Unit 7. We're going to talk about oxidation state, but before we do that, I want to talk about the types of reactions, kind of a review of what we went over before. So, there are 5 basic types of reactions. You have synthesis, okay, you have decomposition, you have combustion, you have single replacement, abbreviate here, and you have double replacement. Okay, so 5 basic types. Every chemical reaction is going to fall under one of those main types. Okay, so there's another type of reaction, kind of a subclassification, called redox, which stands for oxidation reduction. Okay, synthesis, decomposition, combustion, and single replacement all typically do redox reactions. Okay? All typically do redox reactions. So we're going to focus on redox for this first unit, or for this first video, I'm sorry. Okay, so let's scroll down here. Come on. Okay. So, redox reactions are driven by the flow of electrons. Okay? And what I mean by that is, let's say I have a sodium atom and we have chlorine. Alright? If an electron, okay, were to flow from sodium to chlorine, sodium will now be positive and chlorine will be negative. They're going to be ions now. Okay? That's what happens in a redox reaction. It's driven by this flow of electrons. And we've talked about that before when we talked about how ions are formed. So, in a redox reaction, we'll do a pretty simple one first. Let's start with a synthesis. Hydrogen and oxygen can react to make water. Okay? Now, what we're going to do now is talk about oxidation state. So what oxidation state is, okay, oxidation state of an element is going to be 0. Okay? Oxidation state of an element is going to be 0. And I'll show you an example of that in a second. Oxidation state of an ion equals the ionic charge. Alright? So let's look back at our reaction that we just looked at with hydrogen and oxygen. So, let me make a little chart over here. We have oxidation state. Sometimes you'll hear it called oxidation number. Okay? And element. So we're going to look at the reactants first. Okay? Look at the reactants first. So, let's look at hydrogen over here. Okay? Currently, it's not an ion. It's just in elemental form. So its oxidation state, its oxidation number is going to be 0. Okay? So hydrogen, as a reactant, has an oxidation state of 0. Okay? Oxygen, up here, same deal. Right now, it does not have a charge. Okay? Its oxidation state, or oxidation number, is 0. So, let's move this over a little bit. Okay. And let's do products over here. So obviously in a chemical reaction, we are going to have the same elements in the products, since they're just really swapping some electrons here. So we're still working with hydrogen and oxygen. Okay, so now let's look at hydrogen here. Okay, here hydrogen is part of a compound. It's part of an ionic compound, so it's an ion, which means it has a charge. Okay, in this case, the charge of this hydrogen element, or atom, of each one is going to be 1. So we say it has an oxidation state of 1. Okay, now this oxygen, also an ion, has an oxidation state of -2. Since when oxygen forms an ion here, it's got a 2- charge. So we'll say -2. Okay? So basically what happened is each hydrogen atom gave up 1 electron to oxygen. Okay? Remember there's 2. So each one of them gave an electron to oxygen, causing the hydrogen atoms to have an oxidation state of 1, and oxygen now has a -2. Okay? Let's try another example. Alright, let's try a decomposition. Well, let's mix it up a little bit. Let's do a single replacement. We're going to have copper chloride reacting with aluminum, okay, to form aluminum chloride and copper. Okay, so basically, first step, you're gonna identify the oxidation state of each element. So let's do reactants first. Okay. List our elements here, and list our oxidation state or oxidation number here. All right. Draw a line there, show we're splitting up reactants and products. So our elements are going to be copper, chlorine, and aluminum. So on the reactant side, copper and chlorine are part of a compound, so they're going to be ions. They're going to have charges. Now we know that chlorine is typically a 1-, and it is here. It's a -1. Now copper, being a transition metal, can have different charges, but in this case, since chlorine, there are 2 chlorines and they each have a 1-, copper's got to be a 2+ to balance it out. So we say copper has an oxidation number of 2, or +2. Now aluminum, okay, by itself over here, it's an elemental form, no charge, no oxidation number. Okay, let's do the product side now. Okay, same elements, copper, chlorine, aluminum. Alright, so copper is now in elemental form, it's by itself. So its oxidation number is 0. Okay, chlorine was part of a compound here, and it's still part of a compound here. Still got a -1, no change there. And aluminum went from being alone to being part of a compound, so it's got a 3+. 3+ charge, 3+ oxidation number. Okay, so that's how you do oxidation number. So now I want to talk about redox reactions. We've learned how to identify the oxidation state. Now let's talk about the reactions. So anytime you have a reaction, let's look at a simple synthesis here. So we're going to do hydrogen and nitrogen form ammonia. Okay, so there's our reaction. All right. First thing, again, let's look at our reactants and products. So we have hydrogen and nitrogen. I don't know why that keeps happening. We have hydrogen and nitrogen. Okay. Right now they're both in pure elemental form. Zero charge, zero oxidation state. Okay, now let's do the same thing for the products. Again, still have the same elements, hydrogen and nitrogen. But now they're part of a compound, so they're going to have a charge. They're going to have an oxidation state. So hydrogen, okay, one's an ion, 1 plus, and nitrogen, a 3 minus, so that's going to be their oxidation numbers. And that makes sense because those charges balance out in that compound. Okay, so we have our oxidation states. Now we want to take the next step. So, anytime you have a redox reaction, remember we said electrons are being transferred back and forth. So in this case, when you have NH3, you have 3 hydrogen, 1 nitrogen. Each hydrogen gives up an electron to nitrogen. So now they're all going to be 1 plus. And nitrogen picks up a 3 minus with those 3 electrons that it gained. Okay, so again, this transfer of electrons is what drives the reaction. And when this happens, we say nitrogen was reduced. Okay? So let's talk about reduction. So reduction is when an atom or element gains electrons and its oxidation state decreases. So the easy way to remember this, when its charge gets reduced, like nitrogen's did here, its charge went from 0 to -3, its charge got reduced, so we say it was reduced in the reaction. So nitrogen was reduced here. It gained electrons, charge went down. Okay? The opposite of reduction is something called oxidation. Okay, and this is where we get the name redox, oxidation reduction. So oxidation is when an atom loses electrons and its oxidation state increases. So if we go back up to our reaction that we were looking at, hydrogen started with 0. Each one of them gave up an electron, and it ends up with a positive 1 charge. So we say hydrogen was oxidized and nitrogen was reduced. So anytime you do a redox reaction, you're going to have to be able to identify what element or elements were oxidized, what element or elements were reduced. Okay? That's kind of the key to redox. And if you can do that, then you pretty much get the gist of the whole thing. So let's try just a couple examples of this. Alright? So let's try a single replacement. So let's say we have lithium reacting with gold chloride, and we get lithium chloride and gold. All right. So first step, again, identify oxidation states. So we can do that really quick. So the oxidation state of lithium equals 0 here because it's an elemental form. Okay, and we have gold and chlorine. All right, gold's transition. So let's look at chlorine first. We know it's a 1 minus, so gold has to be a 1 plus. Okay, so that's the reaction. So let's look at the products. Same elements, lithium, gold, chlorine. So now lithium is part of a compound, so it's got a 1 plus charge. It's an ion. Gold is by itself. It's got a 0. Chlorine is also a 1 minus because it's an ion. Alright, so that part's pretty easy. Now we need to look at what was oxidized and what was reduced. So to figure out what was oxidized, you see which element increased in charge, basically. Here it's lithium, from a 0 to a positive 1. So we'll say lithium was oxidized. Okay? Lithium was oxidized. So Now we need to look for what was reduced, which one's charge went down. Here it was gold, from +1 down to 0. So we'll say gold was reduced. Okay, so that's really it for redox. You just need to be able to identify oxidation state and then see which elements were oxidized and reduced. So I'm going to give you guys just a couple practice problems and let you work those out, and we'll be done. Okay, let's try potassium and chlorine, or potassium chloride. And let's do magnesium burning. Okay, so what I want you to do, let me scroll down a little bit here. What I want you to do is identify the oxidation state of each element or each atom in the reaction. Do that. Then I want you to tell me what was oxidized and what was reduced. And freeze the video to do this, and I'm going to go back over it when you're done. So freeze it, do the problems, unfreeze it, and you'll see the solutions. Alright, so I'm going to go through this really quick for the sake of time. Potassium's an element, 0. Chlorine, 0. Okay, on the product side, we've got potassium and chlorine are ions, so it's going to be a +1 and a -1. Okay, so oxidized is potassium, charge went up. So that means chlorine had to be reduced. If you have a redox, you never have one get oxidized without the other being reduced, because it has to do with transfer of electrons. If one's giving up an electron, something else has to be receiving it. Okay, second one. Magnesium and oxygen. So, reactant side, neither one's got a charge. Product side, they've both got their ionic charges as they're part of a compound. Okay, so magnesium was oxidized and oxygen was reduced. Alright, that's it for redox reactions. Feel free to try more practice problems. But yeah, that's the basics of it.